Hi guys, welcome back to my channel. Today we're going to be looking at something called the vector product or the cross product. And there's a couple of different reasons that it has these two different names. So the most obvious reason is that when we are finding the vector product, we are finding that we're multiplying two vectors together to get another vector. Okay, so that's why it's called the vector product. And it's called the cross product because as opposed to the dot product, we put a cross in between our two vectors. So the difference between a vector product or a cross product and the dot product is that the dot product is looking for a single value outcome. Okay, so a single scalar value. Whereas the vector product, we are actually looking for another vector. So when we're looking for this vector, now I'm a little bit geometrically challenged, shall we say, so I'm going to do my best here. So let's say I've got my vector A coming out this way, and I've got a vector B that's coming out this way. So when I find the cross product of this vector, it's going to create a third vector, okay, and that's going to be acting in a particular direction. So if I'm moving, so I've got my vector A here, and I'm going to multiply that by my vector B. Since I'm moving this in a clockwise direction, this vector is actually going to come out down here. Now, if I was going to do this the opposite way, so I was going to go B times by A, then my vector would actually be coming out the opposite way. So it really does matter when we're talking about the vector product or the cross product, the order of multiplication. Okay, so an easy way to remember this, think of turning a tap, right? So if you're turning a tap clockwise, so hold your thumb up, so give me a thumbs up. Now imagine turning the tap clockwise, your thumb will go down to the ground, right? That's the direction that the water will flow out, so it'll flow out down to the ground. So we think of this as the inwards direction. It's going into the page. Now, if I was going the opposite direction, so B times by A, so think of turning the tap back off now. So you have your thumbs up. So when you turn the tap off, that's coming back up. So your thumb is now going up out of the page. So it's a little bit tricky. That's the best way that I can explain it to you. So what I'm going to do now, I'm going to give you an example and I'll explain a little bit further what I mean about this thumbs up, thumbs down business. Okay, so here we have three vectors, A, B, and C, and we're going to find the cross product between A and B and the cross product between B and C. So let's start off having a look at A times B here. So having a look, we're going around from A to B. So we're going around in a clockwise direction. So again, I want you to think of your thumbs up, right? And as you turn the tap, you're turning it clockwise, you're turning the tap on. So this is going to go inward into the page. So I'm going to write that at the start. So this is going to go inward into the page, right? So it's going down towards our page. So now what I'm going to do is I'm going to substitute in the values that I know here. Now, luckily for us, they give us the magnitudes of each of these here, so I don't have to calculate them. So our magnitude of A is 4. Our magnitude of B is 7, and the angle between is our theta value here, so that's going to give me a value of 60 degrees. So this is going to give me 28 sine 60 n. So chucking that in my calculator, I get 14 root 3 n, and remember this direction is going inwards. Alright, so that is all that we need to do because we've calculated our vector products. It's this vector multiplied by the normal vector and it is going inwards in this case. So note how we don't actually need to calculate what n is because that's not what the question has asked us to do. So let's have a look at B now. So B is going to be B crossed with C. So in that case, that's going to be equal to our magnitude of B times our magnitude of C, sine theta, and n. So n is this unit vector, this perpendicular vector. And again, it's very lucky because they actually give us this magnitude here. So we know that for B, our magnitude is 7, for C, our magnitude is 6. And if we have a look at the angle in between now, so we're going from B to C here, this is going to be 60 plus 82, so that is going to be 142 degrees. multiplied by that normal vector. Okay, so this is going to give us 42 sine 142 multiplied by that vector n. Okay, so now this time, so you've got your thumb. Now imagine turning the tap off. So as you turn the tap off, your thumb returns back up. So now it's pointing out of the page. Okay, so let's simplify this. So on my calculator here, I've got 42 sine 142 is 25.8577. So let's just round that to 25.86 multiplied by n. And this time it's going in an outwards direction. Alright guys, so that's how we find the vector product. Nice and simple. This is also a formula that is going to be available on your formula sheet when you do your external examinations. Alright guys, so that's the vector cross product. I will see you in the next video.